to Deep Learning Central, where we're going to be discussing about deep learning. And on this specific video, we're going to be looking at a simple implementation of Pytorch. And let's dive in. So the first thing we're going to do, the first step is just basically importing the library. And here we're going to be importing Torch. We're also going to be importing NumPy. And again, from Torch, let's import neural network, and also let's import Optim. Again, let's import Torch summary, check our model. So from Torch summary, import summary. And again, we need to plot our results on a graphical format. So here, this is actually optional, but it's actually good to have it. So import matplotlib, matplotlib.pyplot. FPLT. So the first step is done, just importing the necessary libraries. Now after that, the next step, which is the second step, is dataset. And you need to define your dataset in two formats. One is the input dataset and the target dataset, the target data, sorry, and the target data. So you need to have the input dataset and the target data. I have already created the data, so I don't need to create it from scratch. Let me just uncomment this. It's a simple NumPy dataset having the input data in floating format and also the target data in float format. So, but sometimes it's kind of good to check which kind of data you have. It's an optional step. It's not compulsory, but I prefer checking. So let's check the type of data we have. So for input data type, let's check what kind of data do we have. So input is actually input data, and for the target data type, so let's also check the type of data we have. So target data, and as you can see, our input data is actually NumPy, and our target data is also NumPy. But Pytorch only accepts Torch tensors, so we need to convert our NumPy dataset to Torch tensors. So that step, call it step 3, is converting our data to Torch tensor actually. And here we're gonna, let's just give the name as input tensor, a variable, and we're gonna be using Torch dot form NumPy. Here we are going to change input data, and at the same time our targets, let's say target tensor. Here let's say torch.form NumPy target data. Actually, the same case with our NumPy. Let's confirm whether we have our dataset converted into NumPy. This is also an optional method, but if you want to check, if you want to be sure what kind of data you wanna have, like a print statement to check the type of data you have. So we're gonna change the tensor. Since our variable names are tensor, target tensor, and input tensor. And as you can see, our input dataset has been converted to Torch tensor, and our target dataset has also been converted to Torch tensor. The fourth step, let's say step number 4, will be now the neural network, creating our neural network. And in this step, we're gonna have a simple network of two layers. Let's just call it network. And then we're gonna be subclassing this from the NN module class. And here, let's try. And I'm assuming we have some basics with Python. So here I have this one, and then I'm gonna instantiate again the super. Let me just have self the first fully connected layer, and here I'm gonna be using the linear layers for illustration. And I need an input and I need an output. So my data set has an input of 3. Let me just say a random output of 4. And let me just use the level activation function. There are different activation functions we can use, but for now, let's just stick with rectified linear unit. And here I'm going to be using one from the NN. So here, and also the second fully connected layer, I'm going to be subclassing this one also. Since we have an output of 4, then definitely our input is going to be 4 on this second layer, and our output can be anything. For just illustration purposes, let me just say I have an output of 3. And then let me define the forward method. And for the forward, I have 2 arguments. I have 1 argument actually, x, and here the x is going to have the first layer, and then we're going to have the rectified linear unit, and here it's going to be self value, and the third is going to be the second fully connected layer. So actually like this, and then we need to return x. After this, we need to instantiate the class. So what we're gonna do, let's give it a label as next. So instantiating this class. So after defining your class, sometimes it's good to check whether your model is working or not. So this is something we call sanity check. Sanity. Now let's sanity check, and I'm gonna use summary, and our model name is net. And here we can say our model has like 5 features and an input of 3. And see, yeah, and as you can see, our model is okay. We have 2 linear layers as type of layers we have. We have also the rectified linear unit in between these 2 layers, its shape and its parameters. So actually our model is okay. Then after checking our model is okay, the next thing we need to do is we need to, let me say step 6. We need to define loss and optimizer. We're going to be using Adam optimizer and mean squared error loss. So for the loss, I'm going to say it's criterion. And here I'm using the NN, instantiating the NNMSC loss class. So it's capital here. And also for the optimizer, so let me just say optimizer, I'm going to be using instantiating optim.adam class, and some bunch of arguments here, so parameters. This is the network which we created, the variables, so parameters, and then a bunch of optional arguments such as learning rate. This is the default learning rate, but which is actually 0.001. You can have it or not. It's actually optional. And after defining your loss and optimizer, the next step is having a training loop. So here, let me just say step 7. We're gonna have like a training loop. And the first thing you need to have like some global variables. the epochs. Let's say we have like 1,000 epochs. And then since we need to plot our data on a graph, let's have an empty list. And let's have a look for an in length of like epochs. The first thing we need to do is we need to like uh, zero gradients. So every time a new gradient is created, we need to default it to 0 to stop them from accumulating. So here we're gonna call the optimizer dot 0 grad, and then the next thing we need to define is forward. And the forward, what we're gonna need is the output from our model. We had our data set as input tensor, and from this we need the loss, which actually will be based on criterion. And here we need the output, and also we need the target tensor. After this, we need the backward. And for the backward, the first thing we need to do is the loss dot backward. And after having the loss dot backward, we need optimizer step. Then we need to append these losses onto this empty list. So dot item. And we need to visualize our training loop. So let's just have a print statement. And here I'm just gonna have epochs. And for the epochs, I'm gonna have the first, from the first epoch to the last epoch. So the last epoch is gonna be 1,000. And for the loss, we just have it in the later. So for the loss, I'm gonna have loss dot item. And as you can see, we have our loss going all the way to 0. Let's see where we started. We started with a loss of like 33. So our training is already done, but somehow we need to plot this and visualize in a graph. So it's also an optional step. You can either skip it or actually do it. Until now, we have already trained our Pytorch models. This is just to kind of like visualize. Which step is this? Let me confirm. So this is the 8th step now. So in our 8th step, kind of like plotting our training. And here let's have our PLT dot plot. The first thing we need is a range. So the first range we need to have is 1, and also 1 plus the number of epochs, since they start from 0, so we need to add 1 epochs. And then we need to have our losses, which we appended from the empty list. And then maybe have a label, and let's just say it's a loss curve. And then we need to have the x-axis, so x label. Our x label is actually gonna be epochs, and our y label is gonna be loss. So we are plotting loss against epochs. You can also have kind of like a title. So here it's gonna be loss against epochs. And finally, we need to have like a legend. So let's dot show and see our graph. As you can see, we started with a loss of around 30, then we went all the way to 0 with 1,000 epochs. And this is just a simple implementation of Pytorch with just 8 steps. And if you, there are some things you can do this. We train this Pytorch on a CPU. We can convert this to a GPU, which is something I'm gonna work on future videos. But until now, we have just done a simple implementation of Pytorch. If you want to learn more, hit the subscribe button, and definitely we're gonna learn more together. Until now, peace.